So we are discussing the descriptive type question and answers in software engineering. Draw ER diagram for the following situation. The situation is like that. Account is a relationship between a customer and a bank. So you have a customer, you have a bank, and they have certain relationship like this. And a customer has a name, so customer will have some name. A bank has a branch, so it will have a branch. A customer may have several accounts, so customer may have several accounts, so you can make it like that. I'll just show you. Let us read the question first. Customer may have several accounts of different type and balance. So we can have type and balance. So this is how we make. First of all, the bank can have branches. A customer has a name. And third, that is, since account is a relationship and it is saying that a customer may have several accounts of different type and balance. So account will have the type and balance, the attributes which is with this relationship, and this shows there can be many customer for one bank. So this is 1 to n. Consider a program which registers student for different programs. The students fill a form and submit it. Then this is sent to the departments for confirmation. Once it is confirmed, the form and the fees is sent to the account section. We need to make a data flow diagram using SRD technique. So let us take this. We are making a program which registers student from different programs. So student, first what it does, a student fill a form, so and submit it. This is sent to the department of confirmation. So this is the department of confirmation. Once it is confirmed, the form is sent to the department of confirmation. Once this is sent, or once this is confirmed, the form and the fees is sent to the account section this way. So this is how a student form, registration form goes to department sends the seat info, registration if it is okay, then the fees and seat info goes to the account. This is the SRD technique for data flow diagram. What are the three activities of risk assessment? Risk assessment means first of all identifying the risk, then controlling risk, mitigating risk, monitoring risk. All these are important aspects of risk assessment. So there are three activities which are like this: identification, analysis, and then prioritizing, that is giving them priority. Risk can be identified by a checklist or looking at previously identified risk. Risk analysis involves examining how project outcomes are going to change with the modification of risk input values. So risk priority or prioritization helps in focus on most severe and that may result in some catastrophic. What is a modular system? List the important properties of a modular system. So a modular system consists of a well-defined manageable units to well-defined interfaces among them. Like this. So well-defined manageable units with these interfaces, well-defined interfaces among them. So the desirable properties of these means the important properties of a modular system is that each module is a well-defined subsystem useful for others, and each module has a well-defined single purpose, that is the cohesion is quite high or should be high. Modules can be separately compiled and stored in the library. Module can use other module, and module should be easier to use than build, and module should have a simple interface. Now define these. First we'll start with the aggregation among objects. So aggregation among objects, it represents actually a relationship. So it is a whole or a part relationship. Aggregation may imply containment also, whole or part. Class, what is a class? It is a template that specifies the properties of the objects. It is a template that specifies the properties of the object, and classes have an interface which consists of an operation, a body which implements that operation, and the instance variable which contain the state of the object. So variable saying we have a class, say class A, and we can make an object of class A, and this object This class has a body. This is a body, and it has certain operations along with the variables, instance variable that contain the state of the object. Repeated inheritance. What is a repeated inheritance? If a class inherits more than once, if a class inherits more than once from the same class, then it is referred to as repeated inheritance. A class inherits more than class is inherited by same class again and again, then we call it as a repeated inheritance. Encapsulation. An object encapsulates the data and information it contains and supports a well-defined abstraction. So encapsulation leads to the separation of the interface and the implementation. So encapsulation leads to the separation of the interface and the implementation. Scenario. What is a scenario? A scenario is a sequence of events that occur in a particular execution of the system. Scenario is a sequence of events that occur in a particular execution of a system. So a scenario can be described textually by enumerating the sequence of events, or it can be shown as an event trace diagram in which events between objects are shown. Explain the following: equivalence class testing, user and system documentation with examples and code dumps. So let us explain them. Equivalence class testing. Equivalence class testing is based on partitioning the input domain, that is the values which can be taken as input of a program, into number of equivalence classes, so that the test of a representative value of each class is equivalent to testing any other values. And two steps for this method are: first, to identify the equivalence class by taking each input condition and partitioning it into valid and invalid classes. And we generate the test cases using the equivalence class of the previous step. So the test cases are generated from the valid and the invalid classes. Then comes the next part, that is our user and system documentation with examples, and we'll see the code dumps. So user documentation contains description of the function of a system without reference to how these functions are implemented, and because implementation detail is not there. Examples are installation guide and reference guide, and system documents contain all the facets of the systems, including the analysis, the design, the implementation, the testing, the security error diagnosis, the recovery, the quality. So, for example, we have SRS and system test plan. Code dumps. These are the debugging techniques. So printout of all relevant memory locations is obtained and studied. So all the dumps should be well documented and retained for possible use of subsequent problems. Its advantage are that a complete dump of a memory at a crucial time is obtained. They require CPU and I/O time and can get expensive if it is used indiscriminately. Sometimes it is difficult to interpret the dump, which is representing only the hexadecimal numbers sometimes. Define the capability. What are the quantities that determine the degree of capability of software reliability model? Capability, it refers to the ability of the model to estimate with satisfactory accuracy the quantities which are needed by the managers, the engineers, and the users in planning and managing software development or running operation systems. The quantities are, say, MTTF, mean time to failure, expected date of reaching reliability, resource and cost requirements to reach the objectives. So it refers to the ability of the model to estimate the satisfactory accuracy quantities which are required by all the people who are involved to manage, plan, and run the software properly or SDLC properly. Explain the waterfall model. Explain why it is more advantageous than ad hoc methods. Waterfall model. Waterfall model is a sequential software model process, SDLC, in which progress is seen as flowing steadily downwards like a waterfall through phases of say conceptualizing, then initiation, that is requirement, and then analysis, then design, requirement analysis, and then design, then construction, that is implementation, and finally the testing and maintenance. The first formal description of waterfall model is given by Winston Royce in 1950. However, popular in 1970, and it was further refined by Barry Boehm. To follow the waterfall model, one proceeds from one phase to next in a purely sequential manner. For instance, one or when we complete the requirement specification, which are set in a stone. So when the requirements are fully completed, one proceeds to the design. The process structured as a cascade of phases where outputs of one is input of next, and many variants of model depending on organization and specific project are there. However, underlying phases are same for all. There are variants you'll find. Why waterfall model is advantageous than ad hoc method? This was the second question, part of the first question. The second part, ad hoc process models. So process capability is unpredictable because the software process is constantly changing or modified as the work progresses. So schedules, budget, functionality, and product quality are generally inconsistent. So performance depends on the capabilities of the individual. It varies with their skills, knowledge, and motivation. So there are few stable software processes in evidence, and performance can be predicted only by the individual rather than the organization capability. So to overcome this problem, waterfall model provides several advantages on these ad hoc methods. Waterfall model is simple to follow. However, real projects rarely follow this approach. Iteration is not required. It is widely used because it is easy. What are the objectives of software design? This is the second phase of the SDLCs. That is waterfall. How do we transform an informal design to a detailed design? Objectives of software design. So the purpose of the design phase is to plan a solution of the problem. That is, we have a problem domain and we want to go to the solution domain. So we are trying to plan a solution of problem specified by the requirement document. And this phase is first step in moving from the problem domain to the solution domain. So in different words, starting with what is needed, design takes us towards how to satisfy. It tells us how. Here in problem domain, what was there, in requirement specification what, and design it says how we are going to do it. So there are basic objectives which are like this: identifying different types of software based on the usage, show difference between the design and coding, define concepts of structure programming, illustrate some basic design concepts, and see how to design for testability and maintainability. Non-formal methods of specification can lead to problems during coding, particularly if the coder is a different person from the person who designed the case, who is a designer. So software designers do not arrive at a finished design document immediately, but develop the design iteratively through a number of different phases. So the design process involves adding details as the design is developed, with the constant backtracking to correct earlier less formal designs. So the transformation is done like this. First we make the informal design outline, then the informal design is made, then we make it more formal and the finished design. And these can go bad anytime. Discuss the important issues that a SRS must address. SRS is software requirement specification. So this is the process of establishing the services. The system should provide of the system. In new, it is difficult for software engineer to understand the nature of the problem, constraints under which it must operate. So software engineer take help of a step called the requirement capture analysis. So he first captures the requirement and does the analysis. So it is first formal document which is produced in the software development process, and it serves as the basis of contract between the producer and the developer or the supplier. The important issues that a SRS should address is that first system goals and requirements are different. So goal is a more general characteristics. For example, whole system should be designed in a user-friendly manner or more robust system. What it means? Robust are more testable in nature. For example, all users command selection should be only using pop-up menu. So this is good. For example, it can address various other things like request definition. A statement in natural language stating what services the system it is expected to provide, and it should be understandable by the clients and contractors and management and users. So you can make use cases here. You can use the UML diagram, that is use case here. Request specification, a structured document maintaining the services in more detail than definition and precise enough to act as a contract bill. It should be understandable by the technical staff, both at the developer and the producer's place. Then software specification, that is the design specification. So it is an abstract design description of the software which is the basis for the design and implementation. there should be a clear relationship between these documents and the software request specification. So the reader of this document is the software engineer, system analyst, and the project leader. Then the requirement capture and analysis. It is a process of designing the system request capture through what? First, observing the existing system, discussing a discussion with the users and producer, personal interviews and task analysis, and standard published document reports from the user. Then how to do the feasibility study? It is the estimate which is made whether the identified user needs can be satisfied using the current technology, or whether the proposed system is cost effective, or whether it is possible to develop the system within the budget and the time constraints. So first, whether it is, if at all it is possible, whether it is at all possible in the cost or the time, this is important. And then the suggestion for preparing a SRS document: only specify external system behavior here, specify the constraints on implementation, and this SRS should record the thought about the life cycle of the system, what's SDLC or the software process you are going to adopt, and it should characterize acceptable responses to the undesired events. Explain the throwaway prototyping and evolutionary prototyping. Discuss the differences between the two. Throwaway prototyping and evolutionary prototyping. Throwaway prototyping is also known as the close-end prototyping. So the throwaway or rapid prototyping refers to the creation of a model that will eventually be discarded sometime, rather than it is actually becoming a part of the final delivered software. And rapid prototyping it involves creating a working models of various parts of the system at very early stage after a relatively short investigation. The method this is used in building it is usually quite informal. The most important factor being the speed with which the model can be made and provided. So the model then becomes the starting point from which the user can re-examining their expectation, and then he may clarify their requirements, and the user can tell, and programmer or developer can understand. When this has been achieved, the prototype model is thrown away. The system is formally developed based on the identified requirements. Okay. Then because we are going to discuss the evolutionary prototyping also, the most obvious reason for using the throwaway prototyping is that it can be done quickly. So the user can get quick feedback on their requirements. They may be able to refine them early in the development of the software. So speed is crucial aspect here in implementing the throwaway prototype. Since with a limited budget of time and money, little can be expected or expanded on a prototype that will be discarded eventually. So strength of throwaway prototyping is its ability to construct interfaces that the user can test. And the user interface is what the user sees as the system, and by seeing it in front of them. So it is much easier to grasp how the system will work. Now we come to the evolutionary prototyping. So evolutionary prototyping, also known as the breadboard prototyping, is quite different from the throwaway prototyping. The main idea or the aim when using the evolutionary prototyping is to build a very robust prototype in a structured manner and constantly refine it. So the reason for this is that the evolutionary prototype, when built, forms the heart of the new system, and the improvements and further requirements will be built on that only. So when developing a system using evolutionary prototyping, the system is continuously refined and rebuilt. Evolutionary prototyping acknowledges that we do not understand all the requirements and build only those that are well understood. So evolutionary prototypes have advantage over throwaway prototype is that they are by itself functional systems, and they form the basic or the crux of the next coming system which is added upon it. Although they may not have all the features the users have planned, they may be used as an interim basis until the final system may be delivered. And in evolutionary prototyping, developers can focus themselves to develop parts of the system that they understand instead of working on developing the complete or whole system at a go. So these are a few more questions on our software engineering descriptive question series. Thank you so much. We'll be taking more.